We'll then move on to the insulation resistance test. Of course, I'm not going to read the text to you as it is. Instead, I'll show you the device right in front of you, which is what we will be working on. However, I want to explain something to you first. You told me that in the insulation resistance test, you want to measure the resistance of an insulator. So, how is the resistance of the insulator measured? It's done by applying a DC voltage and reading the current flowing through this resistance, then dividing the voltage by the current to get the resistance value. First, you might ask, engineer, why are you injecting DC resistance? Well, this is also an important piece of information that some young people might overlook or not pay attention to. The idea is that DC gives you constant stress on your insulation, unlike the varying stress that occurs due to the AC wave. That's why we need to use AC and high voltage cables. We use AC testing to ensure the insulation and confirm the condition of my insulation. They tell you that up to a certain stage in the cables, you need to use very low frequency VLF testing first to test cables with AC. And so you have two problems. The first problem is that there aren't devices that provide DC, but that's not the most important thing. The important thing is that DC itself is considered destructive because you are putting the insulation under constant stress. The problem is that if, unfortunately, the insulation has a minor issue, due to the stress caused by this DC, you might end up damaging the entire insulation. Therefore, instead of repairing a specific part of the insulation, you might end up causing complete destruction to the insulation. That's why some people prefer to work with DC for testing and then switch to AC. Anyway, let's focus on the current transformer. In the current transformer, I measure the insulation resistance by applying DC voltage to see if the insulation can withstand or endure constant stress or not. That's the first point. The second point is that I inject specifically for a duration of exactly 1 minute. Why do you inject for 1 minute? In order to ensure that the insulation does not break down over a certain specific period of time as determined by the experts or specialists. And who determines this time period and who? Okay, I will tell you the story behind this, but first let's see. So my test involves injecting DC voltage to put the insulation under constant stress. That's the first point, which is why I injected DC. The second point is that this process involves putting the insulation under constant stress for a specific period without it breaking down. Some people, when conducting this test, stop as soon as they see the resistance in gigaohms and say that's good resistance. No. The test, engineer, is to maintain that constant stress for a specific period without the insulation breaking down. I was honestly working at a station. I was in charge of testing protection, high voltage, and testing for GIS and so on. I was conducting a high voltage test at a 230 kV station with Aramco. In the very last second, while we were doing a high voltage test on the GIS, honestly, the insulation broke down. We could have stopped the insulation earlier, but you can't just stop. You have to keep going. This applies whether you're talking about or even testing on. The principle is the same. You are testing your equipment, whether it's fixed or through, if you're testing in, but without causing any breakdown of its insulation, breaking down and without causing any breakdown of its insulation, right? Engineer, how much should I inject? People ask, how much should I inject, engineer? Some say 1,000, others say 1,500. Some say we always set 5,000 on transformers. Others say we always set 1,000 on breakers. One might mean a low voltage breaker, another a medium voltage breaker. And thus the one talking about a high voltage breaker, neither you nor I nor anyone else comes up with things from their imagination. We certainly weren't born with all this information in our heads, nor did we learn all of it in college. However, there is a standard you follow. For these standards, you have IEE 43 or even IEC in 60264 and 60439 and so on. These provide you with all the 6264, 439 and so on. These provide you with all the that you work on with different standards for transformers, cables, everything in the world. Developer, Appians. Transformers, cables, GIS, switch gears, circuit breakers, watt meters, wires, everything in the world. He tells you its voltage level or operating voltage level, and he knocks on its DC test voltage, and he makes a table like this. I also brought you this table, one of the examples, meaning equipment operating voltage if you are measuring the insulation resistance test. Voltage, if you are measuring, so the whole idea depends on your voltage level here. You immediately go to check the voltage you will inject here. All right. Okay, now I have the device that I will work on. The device has the positive and the two terminals. So once you perform a test between AMO, the secondary, which is with the transformer, high voltage with what is essentially a transformer. So you have high voltage, which is considered the primary circuit and the secondary circuit. So you connect between the primary and the secondary, and between the primary and the ground, and between the secondary and the ground. All right, I will cancel all this now and let me bring the camera here so I can explain to you what I am doing with my hands in this part. I will also send you a video on YouTube for the sake of you to see additional details explained. All right. Okay. Now we are going to talk about, let's put this here. We are going to talk about, or where is it? Here? Yes. Okay, look, engineer, initially for you, any insulation, any insulating material is essentially a resistor and a capacitor. I mean, any insulator in the world is essentially a resistor and a capacitor. Nice. Very good. Okay, there are three that I'm not showing here. You'll find them made, but I put them for you in case any of you want to know and want more information. So I also included them because some of the young people always ask about them. And if we have time in the lecture, I have no problem at all explaining them to you. Okay. Now, engineer, when you apply this injection voltage to your insulation, the whole idea is that this insulation draws current. This tension, but current is divided into two currents. One will flow through the resistance of the insulation, and the other will flow through the capacitance of the what? Of the insulation. Exactly. Very good. So initially, engineer, if you inject AC voltage, what will happen is that this capacitor will now keep charging and discharging. It charges in half a cycle and discharges in the other half cycle, charges in half a cycle and discharges in the other half cycle, and so on. Very nice. Okay, excellent. So what do I want now? I'll tell you what I want. Quite simply, which one of them indicates that your insulation has a problem? The leakage current, as long as this leakage current is drawing current from you, the lower this resistance is, the greater the current passing through the insulation will be. And consequently, what does this mean will happen? Solution is breakdown. So now to get resistance, I want to disregard resistance. So if I inject, subscribe to the channel, that's correct. I'm wrong if charging, and therefore the current that will be drawn in the end for me, the total current will ultimately equal, the total current itself was equal to IR plus IC, and therefore IC will equal 0 after how long? After 1 minute. Oh, what's this 1 minute? That's what you told us about, Engineer Rashad, the test duration. That's why, engineers, he tells you that indeed. The insulating material's gain draws current. Its gain draws current over time. This current, engineer, is very high initially, then it decays exponentially. Enters directly, within 1 minute, it drops almost to 0, meaning from its maximum value to 0 within 1 minute. That's why the test duration for the insulation resistance is how many minutes? I have written this in the slides that you have. God willing, if you open them, you will find them there. But I have made it a hidden part here in the presentation. Okay, so I have achieved DC for two reasons: to put my insulation under constant stress, and this is something we have understood completely. The second reason is so that the capacitor of the insulating material does what? It gets charged. So when it gets charged, it acts as an open circuit, and therefore the current drawn for me is the conductive current or resistive current. Consequently, if you divide the voltage by the value of this total current, it's as if you have obtained the insulation resistance. That's why they tell you it's a test to measure the resistance of what? The insulation resistance. That's what I need to obtain, engineer. Great, engineers, that's exactly what I'm looking for. Now, let's go back here again and bring the camera over here and keep this camera here. Now, let's move on to our device. All right, So here you go, engineer. This is the slide, and I'm explaining to you as I brought it back again, explaining here the types of planes and polarization index. What does it mean? All right. So this is for your reference. If any of you want to know more, or if any of you don't understand it or didn't get it or anything, feel free to send me a message on WhatsApp or even send it to the group so that when I answer, I can benefit you all. All right. Okay. So the important thing for you, while you're working on a device now, is that there are certain things you must keep in mind. The first thing is that when you're conducting this test, it must be this way. Or when you're conducting a test between the primary and secondary, both must be completely isolated from the primary circuit and isolated from the secondary circuit. There should be no relay or meter connected to the secondary circuit, and the primary should not be closed. You should have a power circuit so that when you connect it to a power circuit and apply 13.8 kilovolts or 132, if you connect your cable, you yourself will get an electric shock. So it is necessary, as they said, that the test must be carried out on a disconnected or non-current carrying installation, meaning there is no current passing through it now. You must ensure that your circuit is discharged, meaning that the charge has been discharged. This is done by grounding it, but before you start your test, is that clear, engineers? Very good. Another important thing is the idea that you are now injecting DC voltage, so be very cautious, because if you get a shock from DC voltage, it can be serious. I once received a shock of 5 kilovolts. I was working and I had with me a technician from India, and without meaning to, he thought we had finished the test. So he didn't tell me, and without asking for permission, he wanted to press on for the test. He pressed on while I was cleaning the poles of the circuit breaker. He didn't realize I was behind the circuit breaker, so I got an electric shock, but there was no problem because the device has a current limiter. So as soon as it exceeded a certain limit, it was around 10 milliamps or 8 milliamps in the automatic circuit breaker. I mean, that's quite strong, you know, but we should be careful and take care of ourselves, eh? And we shouldn't touch anything while conducting a test or let anyone enter the zone of the, in my test zone. All right, let me open the other camera for you here. Here it is. All right, here's the camera on my device. Okay. Now, as you can see, what does my device consist of? So, of course, as you can see here, what is this you have, or it's just like your thing? Let me bring it a bit closer. And let's reduce the lighting a bit. All right. So, as you can see, you have it set to 500 volts. And at that point, the maximum resistance it can measure is 2 teraohms. Then at 1000 volts, 4 teraohms. Then at 2500 volts, which is 10 teraohms, then it can be set to 5000 volts with 10 teraohms as well. Then it can measure, meaning at 5000 volts, it can measure a resistance of 10 teraohms. Then you have, meaning you can go from 50 to 5000. What are you, any value you need? Is that clear? Very good. Here you have the positive terminal, and here you have the what? The positive terminal, and here below you have the what? The ground terminal. Nice. Okay. One moment. Here are our selection of cables. Of course, because of their insulation, this insulation must withstand the 5000 volts that you inject, because these cables obviously run through paths. I forgot, and I pressed mute earlier, and just now, I got scared. Okay. Because of its insulation, of course, it might be on the ground or attached to the body of the GIS or the switchgear or whatever. So obviously there shouldn't be any leakage that affects the results. Therefore, your insulation here must be very strong. And you can't use any cables other than the ones that come with the device. This device of mine is from a company called Chauvin Arnoux, which is a French company, just like the device from Megger. Both are the same. It's a megometer device. Or the MIT from Megger, both are the same. You have no problem at all. Great, guys. Very nice. So all you have to do is start here by connecting the positive, and here you connect the other end of the negative. All right? Nice. And you start by having the connection between these. I will start by connecting one of them to and the other two, for example, let's say with the ground. Is that all right? Connect one of them with what, and the other with what, and the other with the ground. Very nice. Okay. Now someone might come and say to me, Engineer Rashad, excuse me, how do you connect with the ground? Where is the ground you have? Do you have a ground here? That's nice. Okay, let me show you the shape of the current transformer here. This is what we were talking about. All right. Look, engineer, these are your terminals. Now, is that right or wrong? You told me it's right. Okay, now, if I touch any of these terminals, I'll show you whether it's the terminal of the first core or the terminal of the second core. So where is this ground? This current transformer is supposed to be in its case, which is ours. All right. And this case is the one that touches the body, the body, the body. So this case itself is supposed to be connected to the ground, especially, let's see here, the base of the base of the base of the base. That's why when I come here to tell you with the ground, who am I connecting here? Are you okay? With what? With the base, which is supposed to, if it goes inside or inside, then it is supposed that its body will be touching the body, or in the end, touching whom? It will be touching the ground. Is that clear, gentlemen? Nice. So now here I am. I will connect this terminal here and the other terminal to the body of the set. Is that clear, engineers? Very good. Now I am supposed to start injecting between the cylinder and the what and the ground, but there is something very, very, very important. What is it, engineer? Now, engineer, you have this cylinder which is like a coil, and this coil you have the lighting like this. Here it is. Here you have 1S1, and here you have 1S2, and here you have 1S3. Engineer Rashad, now I touch any one of them, anyone, engineer, this terminal, all of them are ultimately touching the coil. I want to measure the resistance between this coil, or the insulation resistance between this coil and the ground. This coil is supposed to be placed inside a casing. So this casing is supposed to be grounded in the end, right or wrong? So when I hold a terminal from any of these terminals, if there is any contact between the winding and the body of my city, it means there is a breakdown, whether I measure from here, or from here. It's exactly the same idea. Beautiful, guys. Nice. Okay, how much do I want to inject? I want to inject now between the primary and the ground, between the primary and the secondary, and between the secondary and the ground. So how much will I inject now? 1000 volts. So I select 1000 here. But before I press here, if I press like this now, okay, it will start injecting. All right, okay, and I start by wanting to see so I press here like this to see. And then I go back again. No, I have a better way so we don't forget here in this device. The idea of what I'm doing is I go here to the, okay, and here I choose the 1 in /time. You see it, right? Okay, I press here second in /time. Okay, the one that is written for me is how many? 1 minute. Okay, so this is correct, set to 1 minute. I go back here to the 1000. Okay, and before I do the test, I also press this yellow button, then this button. Why? Because above this button, it is written in white that it is /time means it's either voltage or time, but it shows you the time in the form of a clock in yellow. If you press this along with that, it's like you're telling it to activate the time function. So I pressed it and pressed OK. It will show me the time in front of me counting down. As soon as it reaches 0, it will stop the injection all at once. As we will see now here, the first 10 seconds, it won't give you a result. And after the 10 seconds, it will start to show you your output. Of course, since it's just a trial. Okay, let's go to the number 18. I apologize for the interruption, but here it is right in front of us now, as you can clearly see. All right, then we won't forget it. So of course, after a minute, it will stop its injection all at once and will ask you, how is your equipment doing? And will tell you, of course, my CT is new and I have it here, but it hasn't been exposed to any stress or anything at all. So you will always find that even the insulation resistance is excellent without any problems at all. All right, come here while it's working. I will demonstrate for you as if I'm removing my clamp and touching them to the ground as if something happened during the injection. Look, you will immediately see what the device does. The device will immediately show you that the resistance is less than 10 kilo ohms. and will stop its injection. But if there are no issues, it would continue with you and the device would immediately elevate. It stops as soon as it sees what? It sees that the resistance is less than 10 kilo ohms. This means that the device cannot measure resistance less than 10 kilo ohms. So as soon as I touch these things together as if something happened, or I touch them on the same case as if what happened, as if a short circuit occurs